So in this video, we're going to talk about scaling up and scaling down, provide you with a chance to practice this. So the 6th grade students are making hot chocolate to sell at the Winter Carnival. Each homeroom suggested a different recipe. So you have homeroom 6A, 2 cups milk, 3 tea of cocoa powder, because it means T stands for tablespoons, that's right there. HR 6C, 3 cups milk, 4 tablespoons cocoa powder, 5 milks to 8 cocoa powders, 4 milks to 7 cocoa powders. Complete the table and label the last column with a ratio that will help you answer each question. So a good strategy in these videos is to pause it and copy down and try and figure out the table as I kind of talk my way through it. So the table itself is pretty simple. Like, you're just taking 6A, says cups of milk is 2, and then your tablespoons of cocoa powder is 3. So in like the ratio that would help you, it would be like a 2 to 3 ratio. And then 6B is 5 cups of milk to 8 tablespoons, so 5 to 8. 6C is 3 and 4, so you could say 3 to 4. And then 4 to 7, so you could say 4 to 7. Now I'm looking like if I put these as fractions, could I reduce them? No. So we're good. So this one says, which recipe should the student choose if they want to make their hot chocolate have the most chocolate? So what you could do is you can scale these up and scale them down to see which one is the greatest amount. The other way is to, and I can kind of show you how to do that, where you find basically you put them as fractions and you see which one is the greatest fraction. So you're like 2/3 to 5 to 5/8 to 3/4 to 4/7. So you try and find a common denominator and you scale them up. These ones here would have a common denominator of 24, so we just kind of eliminated the 4/7 for now. You could compare these. So 3 times 8 is 24, 2 times 8 is 16. So let's come over here and find some space to work. So we'd say 16 24ths, and then 5/8 would be 8 times 3, so 24, and 5 times 3 is 15, and 3/4, 4 times 6, so 4 times 6 is 24, and 3 times 6 is 18. So you can see that the 3/4 of those is the greatest, right? Which means it's bigger and more concentrated. So I can eliminate these ones, and I come back and compare that to the 4/7. 3/4 to 4/7 are the two I want to compare. So when I'm just comparing these two, I would have just a common denominator of 4 times 7, which would be 28. So 3/4 and 4/7. 3/4 would equal 4 times 7 is 28. 3 times 7 is 21. 7 times 4 is 28. And 4 times 4 is 16. So 21/28 is greater than that, meaning that 3/4 ends up being the greatest one, the most chocolate. So I kind of highlighted that to show that. The other way to do this would be to use your calculator and actually divide these out. And I'll again rewrite these fractions over here and work on that. Let me correct that terminology. While I'm saying the word fraction, I mean these are ratios that we're comparing here. So although they kind of work like fractions now, they're not. 2 divided by 3 equals 0.66, and that just repeats forever. And then you just do in a calculator 5 divided by 8, and that equals 0.625. So this one's the 2/3 is slightly greater. And we know the answer should be the 3/4. 3/4 would be 3 divided by 4, and that should give us a 0.75 because 3/4 is like 75 cents. Right? And then 4/7. 4 divided by 7, that is 0.5714, and it keeps going 2857. So I would just say 0.571. The 4 says round down, so just get rid of it and keep it 571. and leave that for comparison. Because all we're doing is trying to figure out which one is the greatest. And we can see that the greatest concentration is the 0.75 ratio there. And all of this is all well and good. And then you go back and you want to check your answer, right? So I come back here and I'm like, okay, which recipe should students do? They want to make their hot chocolate have the most chocolate. So I look at my ratio and I did milk to hot cocoa. But then I realized, wait a minute. They want the most hot cocoa. And I just figured it out as like milk was the numerator there. So I need to switch them. And so I'm like, oh man. Luckily, since I've already done the work over here with these decimals, I basically just need to say which one has the least amount of milk. So when I come back to these, which one has the least amount of milk? This one, and nope, 0.57. So the 4/7 has the lowest amount of milk to cocoa, the most cocoa in there. So the 4/7 is the one that I'm going to go with as the strongest hot chocolate. So this becomes my answer. And look at that, you can make a mistake, but as long as you read the question, you can then go back and use the work you have and sometimes figure it out. And then I read ahead to this next one. It says, which recipe should they use if they want their hot chocolate to have the least chocolate? Well, then you just pick the one 3/4 that has the most milk. So, bam, that one was easy. So now with these examples, we're going to, it's about scaling up and down. Just for the sake of time, I'm going to go ahead and just do a couple of these and kind of be done with this. So if you want to go ahead and work on these, you can, but I'm not going to go over all of them. So it says to scale each up or down to determine the unknown quality. There's two ways you can actually do this. One, you can scale it up or down. So like D, you can scale down. Let's say 300 divided by what equals 100? Well, that's by 3. So you do 3 divided by 3, and you're going to get 1. So it's 100 centimeters over 1 in this proportion, scaling up. The other way to do this is to know the multiplicative relationship between the two things in your ratio. It needs to be the same. So I say, okay, 3 times what equals 300? Oh, that's times 100. So then what times 100 equals 100? Well, that's 1. So it still has to be 1 either way. Or say we're at this one, 16 cups to 8 pints. Well, 8 times 2, so it's 2 times greater. So then 1 pint times 2 would be 2 cups. So this also works, 8 divided by 8, scaling it down, and 16 divided by 8, it's still going to equal 2 cups over 1 pint. And we can go to one that scales up. This one here scales up. So 1 times 2, 5,280 times 2 is 10,560 feet for 2 miles. Oops, reverse that. And then you can also say 1 times 5,280 equals 5,280, and then 2 times 5,280 is going to equal the 10,050. So you also want to understand that ratios themselves have a multiplicative relationship between your numerator and denominator, between the two terms of the ratio that are being compared. I'm going to skip this one just because I'm already at 9 minutes and don't want you to sit here forever watching this. So go ahead and work on your WSQ. That is, where and when did I watch the video, a summary, 3 to 10 sentences. I know it's been long, but don't get more than 10. And then a Q, a question you still have or somebody else might have.